primer on surface tension, and not to say that we've covered everything there is to cover about it. There's a lot more I haven't even begun to learn about it. But I have come to realize that surface tension is important. And when it comes down to determining how well, or even whether, a device such as the RainmakerH2O technology works, one litmus test, you might say, is whether surface tension is reduced. If surface tension is reduced, and I've had a number of people ask about this, and say that if surface tension is reduced, and this is confirmed, they have a lot of places for application for this device. Well, realizing that that's important, this is what we've gone forth and done. My colleague Joseph Johnson, in his lab, obtained a device for determining surface tension, and basically put our unit to test compared to some reverse osmosis and tap water. This is what happened.
Yep.
It's recording.
Cool. Okay, so we've calibrated the unit, and our test is to see if structuring water will alter the dynes of a solution. Need this tap water? Anyway, so this is distilled water. This is our reverse osmosis water, which we're using for our baseline. Why is this? So this is, we're going to put it under here and bring it up to touch.
Do you know what the TDS of your reverse osmosis water is?
It's all solids around about 50 ppm.
About 50.
Okay, so we're touching now. Scale 0 to out. And here we go. Standard is 72 to 74. Can you see the break? Can you see the touching?
We can see it.
Notice the beaker. Look at the water. See how it is stretching. That is the tension of the surface just before the break. After the break, that tells you exactly what the surface tension was. That tells you at what dyne rate or level or amount of dynes it took to cause the break to occur. So what didn't happen is that because of the height of that the beaker was set at, they were unable to lift the measuring tool high enough to still show up on the dial. So they need to adjust the height of the beaker and run it again.
Almost there.
Where did it break?
Broke at 63 dynes.
So basically, 63 dynes of force was needed to cause a release of the apparatus from the water. Now that's from the first sample using the reverse osmosis water.
Okay, so we begin again. And we broke at 61 dynes.
The surface tension of regular tap water is generally understood to be around 72 dyne. And so they ran several additional tests to see if it would ever come out to 72, 74 dyne. This water consistently came out at 61, 62, 63 dyne. So you could say, and because it was reverse osmosis water, it had gone through the reverse osmosis process, perhaps it was somewhat soft, perhaps. But nonetheless, the readings were consistently in the 61 to 64 dyne area.
Still at about 60.
So we're breaking about 62 dynes. Okay. So let's do structured water.
Same water.
Same water.
Now that a consistent baseline has been set up with the source water in the 60 some odd dyne area, the next step is to run that same source water through the Rainmaker unit. And while most Rainmaker units, especially even the one that he's using in this example, are put on a line, they are run through pressure, you're going to find that the results are going to be more vigorous, more pronounced. But by using the simple gravity method, by simply pouring this water through the device and using only the force of gravity, this shows that even, you could say, our least, or under the least conditions, you still can, you can count on the fact that this change in the surface tension does occur, will occur, even if you're simply just using gravity. Because in fact our most basic unit is a handheld unit, and it also changes surface tension. So this is pretty significant, because when the units are put online as they will typically be done and the water is under pressure, you can actually anticipate that there will be even greater differences, greater variances in the surface tension. In other words, even greater absorbability, greater efficiency, greater spin state.
Does it make a difference if you run it through multiple times?
You may, we can test that too. So yeah, our structured water.
They need to dry the dipping element, or the apparatus, I guess you might call it. It's a dipper. What can I say? That's what you're doing. They're dipping it down in there. But they need to dry it each time in order to separate and make certain that the previous water sample is not on and influencing the current one. So that's a process that happens every time. Now he takes the first readings from the sample that has been structured through the Rainmaker.
Broke at 40 or 49 dynes.
Wow.
The surface tension measuring instrument is called a tensiometer. Joseph ran several additional readings and discovered that the output stayed consistent within 1 to 2 dynes, from 49 to 50, 51 dynes.
So we're breaking at 50 dynes now compared to what was it before?
62.
So we got about a 10 dyne reduction.
Cool. That's significant.
Yep.
Same.
49 dynes.
Upon taking several additional readings, Joseph discovered that the output was consistent, coming in from 49 to about 52 dynes, and essentially a 10 to 12 dyne reduction from the base amount of the source or the original waters, untreated, unstructured reverse osmosis water. Now, how this compares to regular tap water, which again is understood to be around 70 some odd dynes, they're not sure if it's the calibration or lack of the tensiometer or it's the water itself. But whether the tensiometer is on or off, it is consistent in showing consistent readings from the same group. In other words, the reverse osmosis water is showing a consistent reading in the 60 some odd dyne range. The structured water is showing a consistent 10 dyne or more reduction. And in that particular case, that's, it's almost 20%. It's a little less between, it's almost a 20% reduction simply by running it through using gravity.
You're not getting your drift anymore like you did before.
No, I guess we balanced it out. One being able to get the thing back to. The hell? Okay. 51 dyne.
51.
So we're within 0.2. We're within 2 points. It's interesting that the water has the ability to grab this substance. So we're at 45 and we're already seeing some separation. At 51, it broke off. So we have a definite 10 dyne variance or reduction.
So, I mean, it keeps repeating itself more or less.
Yeah, we have a definite repeatable variance in our measurement.
This is why you spend all day doing it, to really find out at the end of the day what it's doing.
This is fun to do once or twice, but Jesus, living. Yep, 50 dynes. 10 dyne reduction.
You stop there and you just let it go, and then it broke on its own. When you saw it coming up.
Let's see where. Yeah, that's what I was trying to measure the other one too, at the point where the metal plate separates. There we go. So, where the metal ring separates from the solution. Where it pulls off. There we go. 45 dynes. There we go. 50 dynes.
That's it. Wait for it. You have to wait for it.
We got it. 50 dynes versus 60, 62 dynes. So
it's a good solid 10.
what are you saying? Reducing dynes is difficult?
It is. It is. It's not many things to it. I mean, that aren't surfactants. I mean, chemically.
So it's been a very full day of exploration into the subject of surface tension. And before we go, I want to leave you with something else here. Let's not presume that we know all there is to know about it, because I just got off the phone with M.J. Pangman, author of Dancing with Water, The New Science of Water, along with Melanie Evans. And these, well, first of all, they are experts in this area and the dynamics of water. And they've got their their ears and eyes on the pulse of information and cutting edge understanding about it as well. And there is evidence that surface tension, the reduction in surface tension that occurs when water is sent through one of our RainmakerH2O units. The evidence is that this is like a trigger to, it's like a rebooting of a computer. It's the trigger of an event. It's a change of a state, but it is not the end unto itself. It appears as though over time, the water that has become structured ripens. It actually increases in its potential, it increases in its richness, is an energetic richness over time. And so the change in surface tension, the reduction in surface tension appears to be actually temporary. It's like it's evidence of a change in the state of water. But as time goes on, the surface tension and hence the coherence of the water appears to actually grow again. It increases. So the reduction in surface tension appears to be, first of all, it is a positive effect, a positive experience. The fact that we can do it without water, not without water, the fact that it can be done without chemical inputs, without salts and things like that, surfactants, that's very important. But it is evident that once water goes through our unit, it gains in something called coherence. It holds what's called life force energy, and it literally, its field and its field effect, and we've seen this before, it actually grows, it gets stronger. So surface tension, the reduction of it is actually very important, but it's just the beginning of something that continues on over time, and evidence has borne that out. So it's something to consider in conjunction with everything else that we've had to share. Anyway, thank you again for your consideration. We are continuing to learn, and as we learn, we'll pass it on. I hope you found this journey into the Tao of surface tension. I hope you found this journey into surface tension worthwhile. I hope you found it valuable and beneficial to get under the surface of the subject of surface tension. Get behind the scenes and know a little bit more about it. I know that I have at least a better understanding. I may not know it all, but I have a better understanding of what surface tension is. I also have a better appreciation for why the reduction is important, as well as why the reduction does occur when water is sent through a RainmakerH2O device. And that's really the key at this point in time. The places where it really counts, in our health, the health of our plants, the health of our animals, our crops, that's really where it counts. And all of those values are measurable. There are ways to determine whether it's happening or not. And so we invite you to find out for yourself, just as we are continuing to find out and confirm really why this represents a change in paradigms, in methods that we as humanity, we as science, and all as scientists, whether you have initials in front of or behind your name, if you are invested in the expansion of knowledge, there is no agency that stands in the way of you learning and knowing for yourself. So we invite you to do that, and we thank you for your attention. Exit, stage left.